Hello students, in this video we will learn how to find the rate constant and rate law. Now in this question they have given the data and we have to determine the rate constant and the rate law for this reaction, that is N2 gives 2NO. So by using this data we can find the value of the rate constant and also the order of the reaction very easily. Okay, now by using this reaction, first let's write the rate law for this reaction. So rate law only depends upon the concentration of the reactant. So the rate law will be equal to K into the concentration of N2 and O2. Okay, now let's write that. So this will be the rate law for that reaction. Here the X and Y will be the order of the reaction, that as we have already know that X plus Y gives the order. So to find the rate constant, we should find the value of the x and y. So to find the value of the x and y, we need these data. Okay. So by using these data, we will find the x and y. First, let's find how to find x. So to find x, we are going to consider two experiments. Here we have three experiments, 1, 2, and 3. So we are going to take any two experiments and divide them so that we will be getting the value of the x. So for N2 we will be having x and for O2 we will be having y, right? So to find the value of x, we are going to consider any two reactions. So for example, just see here in this experiment 2, the values for N2 is 0.040 and in third experiment it is 0.010 molarity. While for O2 it is 0.010 and here it will be 0.010. So as here the values, both the values are same, when we divide this two rate equation, this will cancel out, right? So if this cancel out, we can easily find the value for the x. So we are going to use the same thing, okay? Here now we are going to consider experiment 2 and 3. So by using the same formula, we are going to write. So the rate will be equal to, here we are checking the rate of second experiment. I will be dividing this by rate of third experiment. Now we will substitute the values, okay? So here you see for the K value, we have 0.040 for the first experiment and 0.010 for the second experiment. Okay, first let's substitute the value initial rate, that is the rate of the reaction for the second reaction will be 500. So then we can write this as 500 is equal to K into, here N2 to the power of X for the what? What reaction? Second equation. So 0.040 into 0.010, that is for the second experiment, right? So it will be 0.040 x 0.010 y divided by the rate of the third reaction. Sorry, third experiment. So for the rate of the third experiment will be 125. So we are going to substitute that 125 K into 0.010 into 0.010. We are just going to consider rate for the third reaction. So it is the multiplication of the concentration of the N2 and the O2, right? So it will be 0.010 to the power of x, 0.010 to the power of y. We are just going to substitute the values. That's it. We are not going to change the proportionality constant or this power x and y. Okay, we are just going to substitute the value. So you see here, we can directly cancel this y term. that is 0.010 to the power y because they are same. So as they are same, we are cancelling it. We can easily find the value of the x. Here the k also will be cancelled and 125 will be divided into 4 times. We will get 500. So how we can write this? 4 is equal to. So here you see this is 0.040, right? So when this comes this side, it will be 4 into 10 to the power of minus 2 to the power x. The same way, when the zeros comes this side, it will be 1 into 10 to the power of minus 2 x, right? As these both are same, how we can consider this? So 4 into 10 to the power of minus 2 by 1 into 10 to the power of minus 2 whole bracket x we can put. So what will happen? This and this will cancel. So what happens? 4 is equal to 4 to the power of x. So what does this mean, children? So what will be the value of x so that we will get the 4? So only when the value of x is equal to 0, we will get the 4, right? So the value of the x will be 1. That's it. Easy, right? Okay. The same way we are going to find the value of y. So to find the value of y, we are going to consider any two data. Okay, any two data here so that it will be like cancelling the values of the x. So for example, if we take consider this experiment 1 and 2, here the values of the x are same. So when we divide these two rates, these will be cancelled and we can easily find the value of the y. Okay, so the same we are going to do this. So to find y, we are going to divide the rate of first experiment and the rate of second experiment. Okay, this is what we are going to do. So what it will be? The rate of the first experiment is 1000 divided by the second experiment. So it will be 1000 by 500 is equal to k into, for the first experiment, the value of n molarity for the N2 will be 0.040 and for O2 also 0.040. So we are going to write it. X 0.040 y divided by, and the rate law for the second experiment will be, for the second experiment the rate law will be the concentration of the reaction, that is 0.040, 0.010. As I have said earlier, we are just going to substitute the values that are in the experiment. Okay, so what happens now? The same way, this will get cancelled, this will get cancelled, the k also will get cancelled, and this will be cancelled by 2 times, right? 500 into 2, we will get 1000. So then we will get what? Here also, like in the previous sum, it is when it goes like this, we will get 10 to the power of minus 2, so we will get 4 to the power of y. So here it will be like 2 is equal to 4 to the power of y. So now we have to find the value of y, right? So what will be the value of y? So that will be equal to 2. So that is y will be equal to half. How it will be half? Because when it is in root, that is root 4 is equal to 2, right? So the value of y is equal to 1 by 2. So now we have found the value of x and y. Now we can write the rate law for this reaction. So what will be the rate law? It will be k into concentration of N2 of Vx, concentration of O2 of y. So by substituting the value of x and y here, Here x will be equal to 1 and y will be equal to 1 by 2. So this will be the rate law. Now by using this rate law, we can find the rate constant, that is the value of k, very easily. What we are going to do is, to find the value of the rate constant k, we are going to take any one of the experiments. Okay. For example, I will take this experiment. So here we are just going to substitute the rate and the concentration of the reactants of N2 and O2. Okay. We are just directly going to substitute them. We can consider any one of the experiment here. So let me consider the first one. So by substituting the values of the rate of the experiment 1, so the rate will be equal to, so let me substitute. So in the first experiment, just see, in the first experiment, the rate is 1000, while the concentration of the N2 will be 0.040 and concentration of O2 will be 0.040. Same only. So by substituting both, what we will get? The rate is 1000. So to easily write the unit, we can now itself add the unit. K into 0.040 m 0.040 m 1 by 2. Here it is 1 only. Okay. As we have known, children, the root of 4, like just consider this thing. The root of this thing will be, how we can change this? 0.040 can be written as 4 into 10 to the power of minus 2. So the root of 4 into 10 to the power of minus 2 will be 2 into 10 to the power of minus 1, that is 0.1, right? So we are going to substitute this value. So it will be k into 0.040 m into 0.2 m to the power 1 by 2. Always remember this, because this 1 by 2 is both for the number and the molarity, the unit also. Okay, so you have to just note it. Okay, so here it will be 1000 molarity per second. Okay, now if we solve this, what we will get? K into, this will be 0.040 into 0.2 will be 0.0080. This m and m, so this will be added because in multiplication, right? So 1 plus 1 by 2, we will get 3 by 2, right? So now what I'm going to do is, now I will keep this constant here and I'm going to take this thing here. So k will be equal to 1000. I will keep the constant, I will keep the unit away, okay, for the understanding. So 1000, this will go this side, so it will be divided. 0.0080 molarity per second, and for this will be molarity 3 by 2. So it will be like molarity 3 by 2. So when we take the reciprocal of it, it will be molarity minus 3 by 2. Okay. So the value we will get will be, these will be cancelled, right? That is 1000 by, when we take this thing dot here, so it will be 8 into 10 to the power of minus 3. And when we cancel this, it will be, and when we solve this unit, that is, this is 1, right? So 1 minus 3 by 2 will be minus 1 by 2. And when the second goes, it will be S inverse. Okay. When we solve this, it will be, 8 will be cancelled 125 times. 125. So it will be 125 by 10 to the power of minus 3. So to cancel this minus 3, Okay, what I'm going to do is I'm going to multiply this by 10 to the power of minus 2 by 10 to the power of minus 2. So what I will get? I will get 1.25 by 10 to the power of minus 5, because minus 3 into minus 2 we will get minus 5, right? So when we take this thing up, what it will be? 1.25 into 10 to the power of 5 molarity to the power minus 1 by 2 second inverse. So this will be the rate constant for this reaction.